Welcome to The Explainer. Today, we're diving into the massive global shift toward electric fleets, and we're going to look closely at how artificial intelligence is stepping up to solve some monumental infrastructure hurdles by 2026. We are at this absolutely crucial intersection right now, where transportation meets the energy grid, and honestly, the data we're seeing on this is just fascinating.
Here's how we're breaking it all down today. First up, the carbon cost of mobility. Then we'll map out the electric fleet transition, look at the actual business of EV fleets, tackle how to overcome charging gridlock, and finally wrap up with AI in the charging revolution. Let's get right into it.
All right, Section 1, the carbon cost of mobility.
Did you know road transport makes up a staggering 21% of all global CO2 emissions? That's a massive slice of the pie, with cars and vans making up the biggest chunk. As our global populations shift more and more toward mobility as a service, ride-hailing and those huge delivery fleets, decarbonizing this specific sector isn't just some nice-to-have goal anymore. It is absolutely critical for our planet's future.
Because right now we're caught in this intense tug of war, right? On one side, we've got our incredibly fragile natural environment, and on the other, the heavy concrete infrastructure we rely on to keep the world moving. Historically, those two things have just fundamentally clashed.
Just to put a number on that tension, major players like the US, China, and India are collectively pumping out nearly 3 billion tons of carbon dioxide equivalent every single year, and that's just from transportation. It's a mind-boggling number, but it really sets the baseline and explains why the industry is pivoting so incredibly fast right now.
Which leads us straight into Section 2, the electric fleet transition. Now, you might think electric mobility is a super modern idea, but it actually kicked off way back in 1832 with a crude electric carriage over in Scotland. Wild, right? We hit a modern milestone when the mass-produced Prius rolled out in '97, but the real explosion? That is happening right now in the 2020s, with mega fleets like Uber, Lyft, and Didi going all in and committing to fully electric fleets.
And as our cities grow taller and way more densely packed, smoothly integrating EV chargers into these shared mobility platforms is no longer a luxury. It's a strict structural necessity. You literally cannot just drop millions of electric vehicles into a bustling city without the street-level charging backbone to keep them running.
Okay, moving on to Section 3, the business of EV fleets. So how do these companies actually make money doing this? Well, there's a serious corporate battle shaping your daily commute. On one side, you've got the highly scalable asset-light model. Think Uber or Ola. They focus on the tech platform. They don't actually own the cars. It's super agile, but quality control can be a real headache. Pitted directly against that is the asset-owned model, used by companies like Moya. It requires massive upfront capital to buy the fleet, but in return, they get guaranteed supply, strict quality control, and direct leverage with the car makers.
But whatever model you choose, it all boils down to the total cost of ownership, or TCO. Here's the deal. In Germany, where the government heavily subsidizes EVs, they're actually 25% cheaper to run over a 5-year span compared to gas cars. But over in the unsubsidized UAE, EV are currently about 2% more expensive to run over that exact same time frame. The math flips entirely based on regional policy, which is exactly why operators have to play this so strategically. Since those margins can get pretty tight depending on where they operate, these companies are getting seriously creative to turn a profit. They're rolling out ingenious hybrid models like charging as a service, where they open up their private charging hubs to the general public, or platform as a service, unlocking totally new revenue streams that go way beyond just collecting a standard passenger fare.
But of course, scaling up like this hits a major speed bump. Section 4, overcoming the charging gridlock.
We really have to stop and ask ourselves, what exactly happens to our city's power grid when millions of electric fleet vehicles finish their rush hour shifts and all try to plug in at the exact same time? Well, the answer is a little alarming. Looking ahead at the data for 2025, over 90% of network operators say that physical grid capacity is going to actively hinder their business growth over the next 12 months. 90%. The grid simply wasn't designed to handle this kind of concentrated, simultaneous power drain.
When you mix fixed electricity prices with these massive peak charging surges, operators are basically backed into a corner. They either have to pay absolutely exorbitant peak energy rates and bleed money, or they have to leave their chargers sitting completely empty during off-peak hours. It's a total operational gridlock.
And to make matters worse, the hardware itself is struggling to keep up. As of right now, 14% of all charging sessions, that's roughly 1 in 7 attempts, just flat out fail because of hardware degradation or software glitches. So now you've got frustrated drivers, stranded cars, and bleeding profits. The whole system is kind of buckling under its own weight.
But don't worry, there is a fix on the horizon. Section 5, AI and the Charging Revolution.
This is where artificial intelligence steps in to save the day, tackling these massive infrastructure hurdles through 3 main applications. First up, dynamic pricing, which tweaks charging rates on the fly based on the grid's load. Second, predictive maintenance, to spot hardware breakdowns before they even happen. And third, smart energy management, to intelligently route power from the grid, solar panels, and battery storage.
Let's take that annoying 1 in 7 failure rate we just talked about. By crunching terabytes of data across hundreds of real-time parameters, things like tiny voltage fluctuations or heat patterns, AI can literally predict when a charger is going to break down. That means operators can schedule maintenance proactively, completely eliminating that frustrating downtime for the driver. It's an absolute game changer.
And the financial impact is just as huge. By analyzing all this data and automatically dropping prices during off-peak hours, AI-driven dynamic pricing has boosted station utilization by an incredible 117% in some studies. It naturally shifts driver behavior, totally easing the strain on the grid while simultaneously skyrocketing the operator's revenue. A complete win-win.
We are quite literally watching a total paradigm shift unfold in real time. The industry has a great way of putting it. AI turns charging hubs into active energy assets rather than passive loads. Think about that for a second. These vehicles and stations aren't just dumb appliances sucking power anymore. They're intelligently interacting with the whole system, storing up energy when it's cheap and abundant, and actually feeding it back into the grid when demand spikes.
So, I want to leave you with this final thought to consider. As massive global fleets go all in on electric, having the hardware alone just isn't going to cut it. Looking toward 2026, is your city's grid destined to be a bottleneck, or is it ready to evolve into an intelligent energy asset? Thanks for tuning into The Explainer.